At precisely 10:47 a.m. Eastern Daylight Time, a controlled explosion of physics, engineering, and human ambition ignites the Florida coastline. From the historic launch grounds, SpaceX prepares another step toward reshaping the infrastructure of global communication. This is the launch of Starlink 10-62. At the heart of this mission is the Falcon 9, a partially reusable, two-stage launch vehicle designed for efficiency and reliability. Powered by 9 Merlin 1D engines, the first stage generates over 7.6 million newtons of thrust at liftoff. Liquid oxygen and refined rocket-grade kerosene combine in a precisely controlled combustion process, producing supersonic exhaust velocities. This is not just propulsion. This is controlled energy release at the edge of material science limits. At 14:47 Coordinate Universal Time, the Falcon 9 pierces the atmosphere, carrying 29 Starlink satellites into low Earth orbit. The rocket follows a northeasterly trajectory, carefully calculated to optimize orbital insertion. Within seconds, it surpasses Mach 1. Moments later, Max Q, the point of maximum aerodynamic stress, where structural integrity meets extreme atmospheric resistance. As the Falcon 9 ascends, atmospheric density drops exponentially, drag decreases, velocity increases. At approximately 2 minutes and 30 seconds, the first stage completes its burn. Main engine cutoff, a moment of silence before separation. In a perfectly timed maneuver, the first stage separates. The second stage ignites its single Merlin vacuum engine, optimized for the near-zero pressure of space. Meanwhile, the first stage begins its descent back to Earth, guided by grid fins and cold gas thrusters. In autonomous flight algorithms, it performs a boost-back burn and re-entry sequence. This is where SpaceX revolutionized spaceflight, reusability, turning rockets from single-use machines into recoverable assets. Encased within the payload fairing are 29 Starlink satellites, part of the ever-expanding Starlink network. Each satellite is a compact, flat-panel spacecraft equipped with phased-array antennas and ion propulsion systems, and autonomous collision avoidance software. Once deployed, they will disperse and maneuver into precise orbital slots. At an altitude of roughly 550 kilometers, they form a dynamic web encircling the Earth. The Starlink constellation represents a paradigm shift in global connectivity. Unlike traditional geostationary satellites, Starlink operates in low Earth orbit, reducing latency to near terrestrial levels. This enables high-speed internet in remote regions, real-time communication across continents, resilience in disaster zones. From rural villages to ships at sea to aircraft in flight, the signal now comes from space. As the second stage continues its journey, the first stage returns, re-entering Earth's atmosphere at hypersonic speeds. Plasma forms around its structure. A final landing burn ignites. Velocity drops. Precision guidance takes over. And in a moment that once seemed impossible, the booster lands, vertically, controlled, reusable. Behind this launch lies a convergence of disciplines: orbital mechanics, fluid dynamics, thermodynamics, autonomous systems engineering. Every variable is calculated in real time. This is not just a launch. It is a symphony of physics executed with millisecond precision. With each launch, SpaceX moves closer to a future where space is not the exception, but the infrastructure. A future of interplanetary travel, a future where Mars is within reach. And it begins with moments like this: a rocket, a trajectory, and 29 satellites rewriting the rules of connection.